start record first. Okay, so yeah, I need to show my screen first. Okay, good afternoon, guys. Let's continue. After we did the non-overlapping windings, then we will go to the overlapping winding machine. You will. I'm not sure how good luck are you lah. I randomly choose. Distribute the slot and pole number for every group. As I saw it yesterday, last night, we have about 16 groups. Three person per group, sana. And then, yeah, please don't simply add one person to become four per group, yeah. Last 2 years, yes, there are some doing like this, which is just simply add one person become four. Because already there's a lot of the so-called blank slot. So try to accommodate each other. And then if let's say it found like this, and then if let's say like, for example, there's a one group without my permission become four person, then please don't blame me on your mark to be greatly reduced, at least half, which means I will mark accordingly for that group, but I will just slash half of the mark from there. So you can email me what is the reason if let's say you want to have a four person in the group. For example, in our the so-called let's say our class only have uh, maybe 31 student. Then which means there's one group have a four student. Yeah, like this. Okay, so I still you can still have a time to search it, Okay, so analytical calculation. So analytical is a mathematical calculation, mathematical calculation of the motor dimension. So every time when we want to do the simulation, first of all, we need to find out what is the motor dimension. And if let's say you've gone through the video learning, you have a lot of questions. Why we want to do this? Why we want to do that? This is why I want to get your hand dirty first, which means you go to try to do it first. The result must become out the same or similar. Uh, it is not necessary to become exactly the same, but it should be almost there, almost there. And then all the material are there, and I've tried to run it, should be no issue lah. It is for you to familiar how to click this, click that, and then to get that. And then you will have a lot of questions why we need to set this, why we need to set that, how to get the dimension. So when you have this type of question, this is the place that you need to find. You need to do the calculation. And okay, so first of all, when we want to continue to start the calculation, we need to have uh, uh, um, some initial value. Yeah. For example, the magnet resonance, relative permittivity, air gap, magnet thickness, B set, and then RSI, ISO, LA, and also number of slot and pole. Usually in this chart, this one we need to calculate ourselves, the stator ball radius. And then second one, I will give you this one, number of slot and number of pole. The rest almost there, almost the same, almost there. I will give you a new set of value, not this one. This one is just a sample. So this one is a 15 slot for pole pair machine, which is overlapping. So first of all, we need to determine whether it is overlapping or non-overlapping. We will use a number of slot per pole, NSPP, NS divided by NP, right? Then what else? Then try this one is okay. So for this non-overlapping winding machine, I won't go in deep, because not go in deep, go in detail, because the calculation is almost the same there. Just that how to define. So this is the number of slot per pole, NSVP. So 15 slot divided by 4 pole, we have a 3.75. Whenever it is more than, this is more than, not equal. Whenever it is more than, sorry for the typo, Typo. Whenever it is more than 1.5, we will choose the nearest integer number. So 3.75, we use 3. 3.25, we use 3. 3.05, we also use 3. Okay? Calculate the average value. Why we want to calculate the average value of the mid-air gap? Because that is the place that we transfer the energy from the rotor to the winding, or from the winding to the rotor. So the higher the value, the better the motor performance. Huh? In the context of, if let's say the motor is well designed, if it is not well designed, then okay. This one will come out in a final exam. So you need a final exam, not open book exam. So this one you need to memorize, but how you do that, I don't know, I don't care. This is recorded. Okay. So BR is given, mu R given, LG given, HM also given. What we need to do is we just input and calculate. So with the remanence value, the kekuatan of the magnet with a 1.12 Tesla, we will get about 0.8296 Tesla in the middle of the air gap for a motor. Same, and then we have like, something like this. Okay, so same figure. Then we need to calculate the WTB, same as well. Flux 1 equals to flux 2 lah. Then we will have a BG times AST equals to BS times ATP. Then what is a BG? Already calculated. AST is a 2 pi RSI divided NS, and then LA. I guess I won't repeat again because I already put slow during the overlapping, non-overlapping explanation. So we just calculate the value, and then we need to put in another right-hand side equation so that we can calculate WTB. Once we calculate it, we need to have a nearest 0.5 value, so which is a 4.5, and then stator yoke. So stator yoke, same as well. We use this equation whereby the flux go to stator and then split into half. Okay, so split into half is a 0.5 WTB, and then slot per pole number. So the slot per pole number just now we calculate is 3.5, right? Okay, then yeah, so this is the value. Then we choose a bigger value, nearest in 0.5 value. Then we want to calculate WTT and WTE. Okay, so we have a BG WXLA is set times AX. Where is it? It is actually at this area. It is actually at this area to this area. Okay, so it's flow like this. Okay, so next, then we will come out this equation where the phi x equals to phi t. So BA like this. Then we have this and this. Then remember B set TT, we always use 1. Okay. Then we use 1. Then we do the calculation, we take 2. After that, we use half of it, become 1. Then we want to calculate the RSB and RT. So RSB and RT is use this equation. Then we want to calculate the machine, the motor parameters for the rotor side. Then we use if let's say we want to find RM, we use RSI yang bigger one minus the LG. Then let's say we want to find RR, we use RM minus HM. So we have this equation. After that, after that, this area of the flux, okay, it will flow to this area, okay, by half. So that's why it's two times, right? The total flux per pole pitch will be 2 times on this on 2 times on this area. Yeah, 2 times. Okay. Then after that, Okay, if let's say you have a less than 0 or less than 2 mm, please contact me. Then yeah, in non-overlapping, yeah, in overlapping we'll use a B1, same as well. We calculate, we get the RSM, then the slot depth. Okay, area of the slot, I guess I already discussed this now. Basically everything calculated. You see this one the same. 41, we choose 41. Then this one winding slot. How many turn per phase? This one is we need to see the vector one. This one is a fixed one just now as discussed just now. Same as well. Same. This one would be wrong for the non for the overlapping winding machine. This is wrong. I will uh, recheck again. But the rest will be the same. Okay, the rest will be the same. So I think end of this overlapping one. So we'll go to the motor winding. Oh, so can we continue for motor winding? Oh, tak dengar.
Hello, doktor nak tanya soalan.
Ya, sila.
Kalau yang overlapping tadi, yang RSI itu dia tak bagi, macam mana nak kira?
Oh, tengok sana. RSI dia tak bagi. Oh, Hani dia tak bagi. Ada. This is a very good question. This is will happen in your mini project. Okay, so for example, let me open up the mini project first, which is a lab mini project instruction. Yeah, so I think this one code. Sorry, not this one. This one. Okay, so this is the slot number that I will give you lah, which means for example, project number 1 will do the 6 slot 2 pole. Team number 2 will do 6 slot 4 pole. Team number 3 will 9 slot 2 pole. Something like this. Okay. Then the value. This one I not finalized yet. Let me think about it. And then there's no RSI given, only the ISO given. Yeah. Then how to get the RSI? It depends on here, this equation. So we have a ABC. Actually, we want to find the RSI. Is come from DSI. DSO already given. ABC is from here. ABCD is from. Wait, okay. Since you are here, I can brief you the calculation. So DSO is given. Then ABC we need to calculate here. Okay, have a look on K. K is depend on here. If let's say it is overlapping, we use 1/2. If let's say it's not overlapping, we use 1/3. Then P is a pole pair. P equals the number of poles divided by 2. And then BG calculated, Bmax given, calculated, given, calculated. Only this one, we need to start from guessing. For example, we start guess WTT is a 3 mm, which is at the top. We can see that at the top. So initial toothpick height is a 3 mm. So when we first round, WTT is 3 mm, we put here, and then we do all the calculation from here. Then we find the RSI, for example, RSI equals to 26.5 mm. And then we did all the calculation. We use the RSI, continue the calculation from here. Because once we obtain the RSI, we can continue until WTT. This WTT, this one. Calculated one. Okay? Just now, let's say round 1. Okay, round 1. WTT we guess 3 mm. Then let's say we calculated WTT calculated is maybe 4.52 mm. So round 2, we need to repeat again because of this WTT in gas minus WTT calculated modulus. If it is less than 0.5, baru okay. Which is, if it is more than 0.5, okay, if it is more than 0.5, then we need to redo the calculation. Redo the calculation. Whereby, let's say just now we said this one is 4.52, right? So the second round, our WTT gas is 4.52 mm. Then if let's say we calculate from the top to the bottom until now, we will have a WTT, sorry, we will have a WTT calculate equals to, let's say lah, it become 3.2 mm. Let's say only lah. So 4.52 minus 3.2, it is still more than 0.5. Then we use this value become the gas value. The third round, WTT calculate, which is 3.2 mm. Then after, sorry, this is gas. WTT calculate, maybe we'll get about 3.1 mm. Then this time we use 3.2 minus 3.1. Okay, it is less than 0.5. Then this one kita baru boleh pakai. This one kita baru boleh pakai and continue the calculation to the bottom. Understand or not?
Faham, faham.
Faham, Okay, thank you very much. And then in your report, please don't put this type of calculation for me. This one not important. This is the process for you to find the WTT conversions. But in your report, you need to put the final one, which means from ABC with the initial value of a 3.2 mm, then you continue. Okay, this is very good question. So any question? Do you have any question more? No more, we go into the motor wiring. Okay, so winding for permanent magnet brushless motor can have any even number of magnet pole. This one is the rotor pole. Rotor pole must be in even. It cannot be 3, cannot be 5, no. And then any number of stator slot, NS. Generally, NS is a multiple of the number of phases. For example, if I say it is 2 phase, so NS can be 1 times 2, become 2, 4, 6, 8. If let's say it is a 2-phase motor. If let's say it's a 3-phase motor, 3, 6, 9, and so on. So assumption, all slots are filled by the phase winding. Therefore, number of slots is always multiple of number of phases. And then for 3-phase motor, NS is multiple of 3. This one. Each slot can accommodate 2 coil side double layer. Each slot also can accommodate 1 coil side we call single layer. Single layer will be derived from the double layer. So everything we go to double layer first. Only balance winding are considered in case 3-phase motor, the angle displacement are 120 between ABC respectively. Which means balance winding means our winding, okay, it must be 120 degree electrical apart. Then coil span. What is coil span? A given coil is a wound from one slot to another slot. It called span. Span means distance. Distance. But usually our distance in a meter. But this span is in degree mechanical. This span is under mechanical degree. Either in mechanical, either in electrical. For example, if a 15 slot 4 pole, the coil would span from slot number 1 to slot number 4, such as 3 slot. This one later I will explain more. This one later I'll explain more when we go to practical calculation. But just to let you know that we can calculate like this. We can use a 3 times 360 divided by NS, and then we have a 72 degree in mechanical. After that, we can convert into electrical. Later, I will tell you. As a rule of thumb, maximum correspond is equal to the next lowest integer. After dividing number of slots, this one we already do it and SPP, For instance, 18 slot, 8 pole, it is 2.25. Then we take 2, the next lower integer, the next lower integer, yes. So another example using 18 slot. If let's say exactly 3, then it will be 3 lah, exactly. So for example, if let's say we use a slot per pole number, we get 0.75, it is 1. If a 1.125, it is 1. 1.5 which is less than or equal to 1.5, 1. 2.25, this is more than 1.5. We take 2. Yeah. Wait, I forgot to. Slide. Okay, so if let's say 3 calculated ns divide by np is 3, then we use 3. The corresponding chosen is 3. So this is different. This is a number of slot per pole. Then this is number of correspond NCS. So slot pitch is the angle. Is the angle of one slot. Angle per slot. So just use a 360 divided by NS. So for example, 18 slot, like this, like this, and like this. We can convert to electrical by using, so electrical equals to mechanical times pole pair. Okay, so mechanical is 20. Pole pair is 6 divided by 2. So which is 3 lah. 3 times 20 become 60. So pole pitch means angle per rotor pole. This is per stator pole. Stator pole or per slot pun boleh. Then you use this one mechanical degree. For example, theta P is a 360 degree divided by 6 slot, 6 pole. Then we have a 60 electrical degree, mechanical degree. Okay, and then times with a pole pair, it becomes 180 electrical degree. This pole pair is actually 6 divided by 2 become 3. So 3 times 60 become 180 degree. Sorry for the typo here. Sorry for the typo here. So this one is a one type of PM machine. Then we can see that red, yellow, blue, or red, green, blue, right? For example, red, 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 red. So we have a 4 coil. Okay, and then it is non-overlapping because only one correspond. Only one correspond. Only one correspond. Only one correspond. Same goes to the blue, 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 then green, 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 green. Okay. This one overlapping. Exactly overlapping means you see, for example, this is red, red, and then the red is overlapped with the blue. That's why we call overlapping lah. Then okay. So this is a half coil per pole per phase. We also can evaluate whether, determine how the winding by using the coil per pole per phase. But I seldom use this one, just to have, just to let you have a glance on that. If let's say this is 0.5 coil per pole per phase, maybe it's wind like this. If let's say it's 1 coil per pole per phase, it's wind like this. It is not definitely the same, For example, this one, the correspond is a 1 tooth, 2 teeth, 1, 2, 3, 3 tooth, right? There's the teeth. Which one is plural? Teeth or tooth? I forgot it. So same as well. 1 coil per phase, right? We have a 1, 2, 3, 4, 5, 5 tooth. 5 tooth. So yeah, there will be different configuration. Just to let you know only lah. Okay. Why the coiling so important for us? Because when we want to excite let's say this is a one loop like this, right? Okay, use the right hand rules. Okay, let's say the current is going like this way. So the force will be going up like this. Then this is the axis. Same as well here. Okay, the axis, the force maybe go here or go here. It depends, but usually it's go here. Nah. When it is go up like here, then the force will come out like this. If you still remember that when we have a coil, right? When we have a coil, then the current in, current out. So when we use the right hand rules, there's a force go in this way, which means V lah, right? That and then it become a magnet, electromagnet, which means with electric it become a magnet. So maybe it become a north pole. Then this is north, then the bottom is the south lah. So when it's excite when it excite like this, the top is the north, then bottom is the south. This south will try to attract this here, which means let's say north is here lah, south is here. Then it try to attract the the rotor pole to this way. For example only, yeah. One another thing is we can coil like this. Previously we only discussed coil like this or coil like this, right? Okay, sometimes we can coil within inside, so which means we coil like this and then we coil another one like this. But seldom we use that. Seldom we use that. Then actually they do that is because just to create some they call lapse and concentric winding. We are not considered in here lah. This is short pitch, this is long pitch like this, but we are not doing like this. So we will ask, Dr. Tian, what is the possible combination for the three-phase PM brushless motor? This is the one. For example, for the three slot, we may have a two pole or four pole. Can we have an eight pole or not? No. Answer is no. Answer is no. For example, we have a nine slot. Can we have a 24 pole or not for the rotor? Answer is no. Only here can be used. Right? Only here can be used. We also have a four phase. We also have a five phase. Depend. Six phase also can. And then this slot per pole ratio will give us the minimum coin torque. Sorry. Um, we have times up. So we rest for a while. And then we will continue later.